As you know, Jason, myself here, and Lisa's gonna, please feel free, Lisa, to jump in anywhere you want to add some more color and detail to what we've presented. I know we didn't share our presentation ahead of time. We sort of threw together. The goal, I think, here is to sort of visually share what you're hopefully going to be seeing when we tour the building in a couple of weeks, and we'll talk about when that might be. Date to be determined, but and also look at some of the details that we are trying to accomplish here to meet all of our Pass House standards. So this is a Theus project. I know we're sort of non-denominational here as far as PHI and Theus. I will move forward. So I wanted to just quickly introduce our team. So we have the development team, Beacon Communities, which is based out of Boston. And they are in partnership with Uptown Partners, which is a local organization. The project is in Uptown. We'll get into the location a little bit if for those of you who are in Pittsburgh. And our design team, so ourselves, Rothschild Doyno Collaborative, Taylor Structural Engineers, these are all local firms. I'm Consulting, who's done many passive house projects. They're MEP, and then our civil landscape is FMG. If you're familiar with them, we already introduced our passive house consultant, New Ecology, and Lisa was our contact there. And then our verifier is building performance architecture. Many of you are familiar with Rob Hoskin. He was going to join if he was able today, but I think he's out at the building sciences summer camp. So it's a little busy. And then our contractor working on the project is Soda Construction, who has done passive house projects in the past as well. So we figured we'd just sort of like zoom out real quick. I don't know if Jason, you want to jump into some quickly go through some of the location stuff. And I guess I should say, please feel free to ask any questions. Like, this is not a very formal presentation. Just jump in. We don't have to wait until the end if you have anything that you want to comment on. So go ahead.
Okay, so for those of you who are familiar with Pittsburgh, Uptown is located between kind of the two big centers of Pittsburgh, downtown and Oakland. So there's been a lot of work to rezone Uptown and kind of establish a new bus rapid transit route. Whole bunch of activity happening in this neighborhood just because it is a connector point between these two nodes. We are right on Fifth Avenue, which we go to the next slide. Off to the right there, you can see downtown. You can see the Monongahela River and South Side in the distance. On the top right there, you can see a little bit of information. I know this is maybe sidebar, but reconfiguring this to be bus rapid transit with a new bike lane and street trees. And so this is going to shape up to be quite a nice urban corridor here.
Mm-hmm. And maybe we can talk about the site a little bit here. We have some the existing structures and ones that were to be demolished, so which are already down.
Yes. There was also that neighboring structure on the corner that
has been a holdout. We'll see.
Yeah. You'll see when you go on the tour, that building is definitely still there. A little bit of an obstacle, but that's okay. This is the view from the Boulevard of the Allies. So you'll see the back of the building as you're driving.
And if you've been down it, it's now visible too, where we have topped out framing just recently.
Yes. You're peeking up above those buildings in the foreground there. So, view back the other way, the Birmingham Bridge, and you can't see it, but Oakland is around the corner. So, very well located. Connection to South Side as well. It's very convenient. This was a little bit about some of the massing as we were trying to be contextual to the urban context. There were some existing row houses that we saw that we kind of picked up on to continue kind of a brick front with a an alternate material on the top, as well as kind of running with the idea of the foundation as a stone base that you see a lot in the neighborhood. But we're trying to create a landmark tower from the Boulevard of the Allies, which you'll see. Starting to diagram some of the new transit routes and things. Anyway, just to set the stage there. This was actually originally, when we submitted this for a PHPA application, this was a modular project. So the entire building was going to be modular with the exception of some of the building core and circulation areas. That ended up changing after the PHPA submission was awarded due to a number of things, such as there was the cost wasn't really panning out in comparison to stick framing it or even panelized construction. It was just too much of a financial constraint, so that had to be switched. But more or less kept the same unit mix, unit count, and a lot of the same constraints. So that's just kind of where we were.
I guess talk about the stories here too.
Yeah. So originally this was going to be 5 stories plus a basement lower level, but due to some of the escalation for construction costs that was happening, we were asked to remove a floor and still keep the unit mix, unit count the same, which really made us squeeze everything and really pushed our building to as far as we could to all the property lines and setbacks. And it's definitely a challenge, but part of the reason was going from a commercial wage rate to a residential wage rate. With just by eliminating that extra story, we were able to save money there. So it was a big constraint, but as we'll get into, our building ended up being a very, very tight, compact building, which maybe helped us in the long run. And just a little bit of information about the zoning. This is an eco innovation district, which really tries to incentivize not just affordable housing, but also sustainable building practices such as passive house. So we're located in the eco district, eco innovation district, and some of the most notable things would be like, oh, there's no parking minimum, so that's very helpful, especially for a tight urban infill site. We had some bonuses we could get for height based on being affordable housing. So number of incentives that really helped us out here.
Yeah, we were avoided any special exceptions, variances or anything, so to get through zoning. Yeah, I can talk to this. So this was just our sustainability commitments as part of the PHPA application. We are now, FIAS design certified as we're under construction, meeting enterprise green communities. We're pre-build certified as well. We're all electric to benefit from a renewable electrical grid. Some of the things you always hear: Energy Star appliances, and then some other building amenities. This came as part of our submission: Wi-Fi provided to all residents, and smoke-free, and a lot of those are PHPA. And I'm sorry, I guess we didn't really talk about PHPA if nobody's familiar with it. The Pennsylvania Housing Finance Agency. I always get the A wrong. So there's tax credit incentives for the developer, and so you submit into PHPA. It's highly competitive. This is across the state for Pennsylvania. I mean, every state has their own systems like this to incentivize affordable housing as well. And one of passive house is one of the options to basically rate you on a point system and helps to get awarded here. It's not always done with these PHPA projects, but it's really helped push forward passive house in Pennsylvania. I think was one of the others could probably early adopters as across, and I'm sure Jim or even Lisa probably knows more. But
Can you remind me, was
Mhm.
this also the code compliance pathway? I'm thinking probably not. I'm probably
No,
okay. Which it would
yeah,
be a nice case study for, kind of like as Pittsburgh develops like a passive house pathway and
mhm.
how they would use a woofy passive model to, to measure these things so far as energy code is concerned.
Yeah, yeah, absolutely.
Rebecca, I'm curious, was Passive House always part of the plan for this project? Was it part of the PHPA points determination that bumped it in, or what was really the driving force for it?
Yeah, I don't know that I was on one of the early conversations. I wouldn't say I was in on it, but Beacon Communities has done other passive house projects
Hmm.
in other states. So they, I think a lot of it comes from having a developer who's familiar already with it. So they were open to it, where we've certainly had
Good.
discussions with other developers on other projects, and it hasn't panned out because there's options and they change every submission cycle. Net zero is an option, it gets you different points.
Hmm.
One of the differences now early on with passive house, you didn't necessarily, you have to get certified at the end and meet that. And I don't know what the ramifications of not meeting it are right now.
That was going to be my
But
other question, but yeah.
yeah, I don't. Yeah, probably a knock against the developer on future projects, if or something like that, or considerations, on future awards if it wouldn't meet it after we're done with construction. In the past and years ago with PHPA submissions, you had to have the pre-certification
Right.
uh, in place, and there wasn't necessarily the restraint of getting fully certified at the end. So there was some leeway there, and I think that probably changed along the way. Um, so this is actually a cross section of our building with your 5 passive house principles that many are probably familiar with continuous insulation, an airtight envelope. We've minimized our thermal bridges, which I think we have very few on this project. I'm not sure if we ended up having to model any. Lisa can correct me if I'm wrong. And then high performance windows and doors, um, and the fresh air with heat recovery or ERV, which I'll show is on our rooftop. Let's get into it. Um, so I just threw up here our Woofy passive results. And one thing that Lisa and then Nick Hernandez, who was the modeler for this project for New Ecology, noted is how far we exceeded, with large buffers, the criteria and all of the targets you'll see there. So your heating and cooling demands, your heating and cooling loads, and even the source energy. So I think Lisa noted to us, you want to have at least a 10% buffer going into construction for changes and other things that just inevitably happen, and we're positioned really well. And I think that's for um, a number of reasons. Our form uh, is really compact, so our surface to floor area, that ratio that they look for, really helped us out. Um, we probably should have put in a site plan, but we're also oriented, like the front of the building's directly north, south, so we're elongated along that east-west corridor. Obviously not our choice. We just got lucky with the site. So I think that really helped with a lot of the meeting those targets as well. And some of the moves, the form, as Jason was talking about, early in design were not necessarily because of passive house, but as a result of zoning the site we were trying to fit on, other restraints of fitting in the number of units, and then, as he said, lopping off a floor early in design. Our 1 bedroom unit is, I think, what was the wording, like the most efficient, tightest they have ever seen. We have hit the minimum square footage. So one of the things that we're really emphasizing during construction is they have to meet our dimensions. I mean, from outside a wall to outside a wall, but every single unit, we have this is not advisable to design this way, but we have very little tolerance for our dimensions within the units and across the entire site, really. So any little dimension that comes up, is getting questioned if it's not exactly meeting. And we've had a lot of those questions recently because we just finally have been framing in the past 2 months, I guess, or so, after many delays, which we can get into.
So it's, I'll just say real quick, like in my experience, it's just like now as a project is going along, it's fun. It's like, I know that like owner, architect, design team is sad to see it getting like denser and smaller, the building. But like from my point of view, I mean, you have 9, 10, like 11 3-bedroom apartments in there, 9 2-bedroom apartments. So there's like not even studios. They're all 1 bedroom. So it's occupants heavy, like as much as it could be so far as these kind of units are concerned. So watching the occupancy and the number of bedrooms rise, and then like obviously taking off a whole like so much square footage of envelope, but then keeping the same number of units was like it's a huge deal. And you can obviously see it so far as where those targets are and how far we were from them, how much better we were than those targets.
Yeah, we have 51 units overall. Thank you for noting that mix of mostly 1 bedrooms, 2 and 3. It is a general occupancy. PHPA can do senior. This is not age restricted, so they expect families to live here as well, which is why we have a mix of 3-bedroom apartments as well, which is hard to find, I think, in rental housing. Let's see.
If you wanted to, you're going to go to the exterior envelope next. That's great. I have pulled up the thermal bridges that we did have to just sort of work through. We didn't have to model any, but we did work through a few on those like sticky, like parapet situations and stuff like that. That is the kind
I have some of the parapet details too.
Okay.
And things up. But I just want to like throw up the very overall where we were with the envelope before we get in to the drawings. And I think one thing to note, I know that we went back and forth on, I think we had initially accounted on the exterior wall for, planned for 4 inches of continuous insulation. We are doing mineral wool, and I think through modeling, we brought that down to 2. You can correct me if I'm wrong. 2 inches of continuous on the walls. So, I think I planned for the worst, and bring it down as you go was maybe a strategy, as well as far as detailing it. So, and also just as far as cost, so that early cost models, accounted for more insulation, and then it got better rather than worse as we went through different cost exercises. So, let's see, other thing. Go ahead.
No, sorry, that's my kid.
Oh, that's okay. I thought we had a question. We do have the typical passive house windows. We had Intus are getting installed, and then thermally broken storefronts and doors, as are typical. I did sort of emphasize we're doing GPS insulation under slab, which if you're not familiar with it, is a lower carbon. It's not, carbon wasn't necessarily a goal, or we didn't have any targets reduction necessarily in this project, but just trying to start to change some best practices of the materials that we use on the project. So Sorry, this one might take a second to load. All right, so I threw in, so here are air barrier diagrams. We'll use them as our plans as well, and I can zoom in as needed. So on the ground floor, which on the front side on Fifth Avenue is below grade. So we ended up with a lot of generous storage and mechanical space and maintenance space that you don't often find on a project because of it being below grade, and decided to excavate it anyway because of some of our soils conditions, that they needed to go down that far. So it made sense to actually provide a conditioned space where we knew we couldn't put units. So you'll see these are sort of our typical 1 bedrooms. We have a 2 bedroom here, and I'll get into this, but we do have a trash chute and trash termination room. So the red line is our thermal and air barrier. A blue line, which is really specific to the trash termination trash chute, is just air barrier. You don't need thermal around that. And then we do have unit compartmentalization required as well. So we'll have, we have air sealing between units in the corridor as part of Energy Star multifamily, I believe. Correct me if I'm wrong. So I'll move up to like a typical first floor. And one thing I had done previous, which was new to me, I think newer FIAS versions, in the past, this is our trash room and we have 2 trash chutes, actually, one for recycling, one for trash. That could have been outside of the thermal or passive house envelope. Also the laundry rooms. This is our laundry room that we have only 2 generalized ones. And Lisa, I think I think that was now a requirement of FIAS that those have to be included in the passive house thermal boundary. So really the only thing, the areas in gray are the only portions that we could exclude from it. So literally the trash chute itself, and then the trash termination room on the ground floor. So that, provided some different challenges. A lot of times in the past, you'll have the air barrier around the entire room. So I'll get into the details of the trash chute. And then our upper floors are pretty typical. So we'll jump to section. A minute. These are section diagrams here. So just quickly, that's through, again, purple line's compartmentalization, red is air and thermal. I'm going to jump down to, so you can see what I mean by the trash termination. So only the trash chute and the so we'll get into the detailing of this, and then the trash termination room is outside the boundary. Keep moving here so we can actually get to the good stuff. So I'm going to work through just some of our typical details, and then we'll highlight a couple of others as well. So our foundation to wall transitions. Oops, I can do that. We have, I think one thing to point out, and maybe Lisa, you can explain the extension of our insulation past the still plate connection. I think was something I learned on this project, I guess.
Yeah, it's always kind of a weak link because it's a place where you can through modeling, and you can actually find condensation occurring in that location. So it depends on like FIAS doesn't want to see a break in the insulation right there outside of at the sill plate where the sill plate attaches to the foundation wall. So in the field, we've seen the like mineral wool from above pass down, which would have been fine, just pass depending on what's happening with the grade. Also, interestingly, we could also keep that last bit of insulation off, like almost always at the very beginning when when on site, when you're watching the insulation go on to the foundation wall. Sometimes they want to put it on and the walls are like getting erected, or sometimes, but it's always cut right there, you know, so you have to like make them aware that they either need to hold back, cut down, cut some off, hold back, and then have one extra piece that that deletes that like a joint right there at the
Bridges, sort of
foundation.
bridges the
Yeah.
joint. Yeah.
And you have to pass it with either the upper or the lower insulation.
Yeah.
So we just discussed that a lot because it had just happened on a couple of projects of ours. And so we did, in this case, we just brought the foundation insulation up past, and it really doesn't have to go quite as far as one whole block height, but it was logical for it to be there for the weeps to be on top. But in this instance, but it really only needs to pass by like an inch or two.
Yeah, so I think just overall we have a fluid applied air barrier on the walls. Above grade we have mineral wool. The underslab air barrier that, zoom in, it's our dotted line here, has the typical flap that you see. It has been cut on site, of course, in some locations where it shouldn't have been, and had to be repaired and taped back together so that it can then fold up and attach to the air barrier. And one challenge we've recently come across is understanding we're using the R-guard on the exterior, that a lot of tapes do not adhere to that or are compatible with it. So this is a detail where it's overlapping that we're looking at right now, is actually providing a turn bar with sealant on it so that it can actually hold up. Maybe Lisa, you weren't even aware of this. Rob has discussed this on site, and part of his review when they were doing, we had a small mock-up wall that went up as well. So it was just something that maybe we could have addressed earlier or detailed differently had we known about the compatibility of some of the tapes and liquid applied air barriers. And I guess I wanted to point out, because it'll come up in a different detail, where you don't often see we have a second layer of block holding up where we have brick veneer or brick, but only where it goes to a certain point underground on the front side of the building. So I'm just gonna move so we can keep moving here quick to this was a detail that we worked through. We have a brick ledge. So initially, we had proposed taking that similar detail that we were just showing the whole way down, but that's a lot of extra material to go below grade an entire story with block to hold up the brick veneer, brick or stone. We have a combination of things on this building. So looked at this detail to create a brick ledge to hold that up. And so this is it formed, and then the insulation we have the air barrier that's applied to it, but the insulation will come up under the brick ledge, and then this insulation that is sitting under is I forget which product we ended up with as structurally what's the word I'm looking for, can sustain higher PSI. And that was reviewed by our structural engineer. So only on that horizontal piece on the top of the brick ledge will that particular insulation be there. Anything else to highlight here? It was a little bit different. Keep going. Jason, you want to get into, we'll talk about our soils issues, because this will get into a detail that we then had to work through during construction.
So, we talked about how nice and tight the barrier was, and we didn't have a lot of form. The form was very boxy. We didn't have a lot of ins and outs. But then we had this issue come up where we had this water infiltration happening from an extant water line that what are they called? PWSA didn't even know existed or something like that, and water was pouring in and the soils were a mess. So there was concern about the neighboring property, the neighboring walls collapsing in with the amount of excavation that we had originally planned to do. So there was a field change that had to happen where we essentially had to do a match slab for the bottom flight of stairs in our stair tower. We ended up having to change a 2-bedroom to a 1-bedroom. It introduced all sorts of there was a grade beam. I don't know if we have another section of it on, but anyway, it added a lot of surface area that we didn't originally have, and a lot of new surfaces to waterproof.
Well, I would say I don't know that it changed our building surface area.
Just more
per se.
more
it's
tricky.
Sort of like pushed into a corner. More tricky detailing, yes.
Yeah, sorry. So on the left there was, just a simple stair tower built into the grade, and then where we ended up, we had to put this mat slab in and figure out all the air sealing details around that.
Yeah. So this is actually, this was a section sort of in front of this section. I should have probably put in another one, but we have a underground vertical wall transitioning to, a slab. And how do you apply the air barrier to that in the order? So this was actually a sketch that Lisa and I talked through on a call to start figuring out how do we get this on there. So you have we're trying to talk through my order of things ends up numbering the air barrier is, your typical underground air barrier is liquid applied, waterproofing on your vertical concrete stem wall here. And then we're looking at, okay, so then you have to put this insulation in up to a certain point, allow some space to be able to overlap, sort of lay your under slab membrane, but allow overlap here because you can't pour this until all of this is, set there. So just thinking through the constructability of things, I don't know, and how the order of stuff, I think, is the point here. And this was something we had to do during construction because of the change precipitated by the soils issues. So that resulted in our, cleaned up detail here with the order of things as well. So I don't know, anything else to add there? And then we reviewed this with the contractor to make sure that they understood the importance of maintaining the air barrier and the order of these overlaps. So, questions?
I'm just curious. I have a question. I mean, I'm not an architect, I'm a designer, but with the amount of flooding that we now plan for, are there ways, maybe this is more for Lisa, I mean, have you considered other ways to approach large projects like this that protect for these once in 1,000 year floods? I'm not sure if this is even possible.
I am working on a project that is planning for floods in Massachusetts and Salem, Massachusetts. And in that, so far as Passive House, what Passive House's sort of principles dictate is just that you come from a high level, you come from a place where water is going to be there. So you're going to make places for the water to move through the building. And in those locations, they are flashed all perfectly and as great as these, there are special vents that will open in the case of a flood, essentially. And they have an insulated door, I guess you could say, on them. So that you basically just sort of either need to account for replacing all of the material that is like the finished material, like the drywall and the insulation, like that is included in that layer. So either you're going to replace all of your fluffy insulation and gyp in the case of a flood. FIAS seems agnostic as to that. Like they're not gonna like, won't permit a building that is in a floodplain that it's if its floor level is below the base flood. A new construction, like that's not going to happen. You're going to be above. This building that I'm working on, that I'm referencing, is planning for even the level of the floor to be even taller, but then also just knowing that they're even kind of bomb-proofing this building, and they're actually working. We have like 2 cement-based walls with like a foam insulation and sandwiched between them. So when water does go through in the sort of sacrificial first level of like lobby and gallery and like multi-purpose room space, you can get the water out, and then the finishes are in theory like pretty resistant to moisture. So it will be able to dry out, and they won't have to like replace a lot of the different types of insulation that you would see in a wood frame. For example, they are taking all their CMU and their formed concrete up to level 2. So we would like be thinking about the building as like a plinth building, where the first level is actually like a material that's either steel or concrete, and you wouldn't have the wood. So there's a lot of ways to like go about it, but you just need to understand what you would need to be replaced. And then also around all of those penetrations where the water is going through, you see like in this section, if you had above that a way for water to go through, you would need to flash it like any other penetration, and there's like a multitude of ways of flashing on from the outside and from the inside, and then keeping that door insulated.
Awesome. Thank you.
Yeah. Yeah, our water issues were not flooding. They were
already in the ground.
Already there, already in the ground, water lines. And there were actually multiple ones. Jason's referenced just one, and which is why we've had months of delays on this project as well. Let me jump through, I guess, just some basic window to wall details here. We do have one unit with windows that is an exterior concrete wall. Most are wood, just because of it being partially under grade. And these are really not any crazy, insulated, over insulated sills or anything like that. We, we're able to, through the modeling, be pretty simple, I think, with what we did here. So, and even where we're setting the window, we just went through this with a contractor, because I think windows were starting to get installed maybe yesterday. I'll see on Thursday when I'm there. So oftentimes you see those pushed out into the insulation layer. And we, didn't need to do that on this project as well. Any other comments here? I'll shift over, I guess. Yeah, similar here. We do have a couple of sunshades on one of the back corners, so wanted to make sure we had continuous insulation through there, and we have insulated headers as well above the windows. I'm going to keep moving since we are at 50. Some of the roof, particularly here, I remember this issue coming up, Lisa. So we are insulating over our parapets, kept them at minimum height so that we didn't need any kickers behind them, so to extend structurally, and they're integral to the roof trusses as well. But I think one of the points that just came up or during the end of the FIAS review was, I think, some concern over moisture in the parapet, and then also this transition. So what we've shown is basically a little thicker area where you have this sort of sill plate of the parapet as well. So we already had shown closed cell spray foam at your floor and roof levels joists and where it connects to the exterior wall. So just thickening that corner helped mitigate, and maybe Lisa can explain that a little better, the moisture concerns that Theus had with the parapets.
Yeah, can you remind me what's the material in the parapet? Like, what is the material?
So we actually had changed it. It's not shown here to closed cell. That was a concern. I think we had shown at one point blown in cellulose.
Okay.
And there was obviously a concern there. That was probably not the best first choice. And so it's changing also from a constructability order of things. They're going to do closed cell spray foam in the parapets now, which we already had it at the floor and joist location anyway, so it wasn't introducing a new product there.
I think they also if you needed to, like, for cost or something, have a blown insulation there, I think that fiberglass insulation, a blown in insulation works there, with also that sealing that condensation risk that would be coming from air traveling from inside the truss cavity just into the parapet and condensing on that sill. That's one of the, like, little weak points. But I've seen also the fiberglass work in lieu of the cellulose in there.
Mm-hmm. Other questions there? So I wanted to just highlight, I'd mentioned the trash chute.
And one more piece that is important to that I forgot to mention is the permeability of the vapor barrier that's on the outside, so that it can breathe to the outside. It can't breathe to the, like, roof side because of the board insulation, but if that wall can still breathe with the vapor, just like the semi-permeable, like, Prosecco that you have on that outside, the liquid applied air barrier. They wanted to confirm that when we were talking that through with Theus. That's it.
Good point. So yeah, as we were talking through, I mentioned the air barrier around the trash chute. So you think about this, and how do you do it? Is what it comes down to. How do you construct this thing? So our air barrier is on the inside of the framed trash chute, and this was our initial diagram when we were talking through it. You really have to leave this section of wall where your door goes in last, so that we were talking about bringing the air barrier out so that we can actually overlap it, and it moves to the outside of the wall of the trash chute. So you can I really should have put red lines on here.
Can you remind us what that material is? It's a spray. Is it a liquid applied?
Yeah, it's spray. Yeah, it's a liquid applied, which, we've had some discussions. That's obviously going to be a challenging space. That's really 4 stories tall and not very big to spray. One of the discussions I think we had, where we have actually, I think our other trash has the double layer, was they wanted to put it in between 2 layers of gyp because they were worried about the exposure. But it's not an exterior application, so there's limitations, which we sort of felt was unnecessary as well. So you'll be framed, your shaft liner, everything framed, come in and spray the 3 walls of it, and then I guess install trash chute, and then you'll frame overlap with tape this. There would actually be a split here on this gyp, and go in between your outer 2 layers of it and tape it, and then seal it back to the trash chute door as well. So looking forward to getting some pictures of that going in. We will see. And just to highlight a couple of, so as I said, the trash termination room at the bottom is outside of the Theus boundary. And a couple of areas to look at are obviously where it penetrates the roof. So we have a detail there and how it connects to your the air barrier on the roof, and then I'm also about running out of time. Your connection to the trash chute. And so these are things, I just wanted, maybe we, I don't think I had too much. I wanted to, we can come back to this, or this could be a tour thing that we talk about as well. On site, we can see where we are when we do the tour. So I wanted to just really quickly highlight some of our systems. So we do have centralized domestic hot water system in a mechanical room that was on the ground floor, with fully integrated heat pump water heaters. So there'll be that serve all of the units. So that does not have to be separated or metered, because the building owner will be paying for the water, or it'll be integrated, into the rent costs, rather than paying a separate water. That was something that was discussed early on. And a lot of times there's advantage with affordable housing projects like this, that you can structure it that way versus like market rate units. It's often not accepted by the developer. We have individual fan coil or VRF systems. They are vertical, so like concealed floor standing ones. So that was one reason. Here's our very, very tight minimum 1-bedroom PHPA square footage unit. So you'll see the VRF here on the exterior wall. So that's ducted throughout the unit. And then in 2 bedrooms, 2 and 3 bedrooms, there will be 2 units to serve the larger square footage units. So I just want to quickly get into that. We have our plan detail, and then the dimensions of this have changed a little bit in construction. So just coordinating that early is helpful. ERV, we have one centralized one located on the roof that then ducts to all floors. And I know I've seen it sometimes where it's ducted per floor. So we have one large shaft, and that serves, there's a floor plan, comes down through this shaft from the roof and services each floor. And then the exhaust from the kitchens and bathrooms is tied into that to exhaust through the roof. And really had to do it like this too. I mean, we didn't have any site area to put any condensers or anything like that on it as well. So I know that was sort of a quick wrap up there, but I wanted to be sensitive to time. If you have any questions, let us know. And we will very quickly work with the PH Jim and on coordinating a tour date. We're thinking early September, so potentially in about a month here.
Yeah.
And this is a picture of where we were, well, almost 2 weeks ago now. So
awesome. Anybody have any questions? I know we're up against
Lisa's
time,
talking.
If like kind of nerd out to at those HVAC plans, if you want to talk about just one thing that I see a lot of things that somebody who like cares about that might find interesting. If you go back to a unit plan, you can see how zoom into that to the unit 2. You can see how those units are in the middle of the bedroom and living room areas. They're not ducted. They just shoot that, they just do the conditioned air from right there. And then the ERVs are delivering the outdoor air, just sort of like by that walk-in closet, and another one delivery point is the other closet from the bedroom. And so you don't have ductwork going all over. That's a real savings in cost. And also because the envelope is so tight, you don't have to bring all that heating and cooling and conditioning to the exterior wall. Everything is like also tight back into the apartments, and it reduces any inefficiencies in delivery and cost so far as and duct sealing and all of that stuff. So it's a great efficient HVAC design as well.
Yeah, thank you, Lisa, for pointing that out. And probably ideally this would have been more centralized in this unit would have
It
been
could have
better,
been,
but
but it doesn't have any ductwork, so it's
yeah.
okay. Those rooms are so small. The delivery of the outdoor air for that is over by that closet, the double door closet to the bedroom.
Mhm.
So that's really like all you need in that entire unit. It's just like the one delivery of from coming from your ERV, and then the exhausts from the bathroom and kitchen, and then your heating and cooling right there, right in the living and bedroom area. So
Yeah, I should have put in some mechanical plans, but you can see where these exhausts and go
yeah,
into the
well,
units
those
at
are
least.
just, yeah, those come in and kind of just,
Yeah.
they hardly have to do much, and they're not very long, and they're all round solid ductwork. That's it. That's my spiel.
Yeah.
That's it.
No, it's a great point, because a lot of times with more intensive ductwork in units, for apartments, you have a lot of coordination with the trusses and
Yeah,
boxing out.
that can be hard. That can be hard. And just kind of talking to the mechanical engineers and having them understand that they like don't have to bring it all to the wall, to the exterior wall anymore. There's not going to be a bunch of transfer of heat and air happening right there. If this is a passive house design, the room and the airflow in the unit will kind of take care of itself if you put them in the right spot, but you just don't have to bring it all to that exterior wall.